Hello and welcome to part 5 of our series on sulfur. This is Matt Montgomery, Burris Sales Agronomist, and today we'll be talking about how sulfur exits the soil through leaching. Now I want to remind you where we are in the overall outline for this series. We're almost halfway through the series at this point. We started by talking about basic information, what sulfur is used for. We've talked about plant availability. We've talked about major and minor sources of plant available sulfur. Now we're talking about exiting the cycle. In particular, we're going to talk about leaching. And then we're going to go on from here next time around and talk about how sulfur is lost as we harvest material and how it can be lost into the atmosphere. Our theme for the series remains the same. It's always look to the cycle. The reason we say that is many of the questions we have with sulfur can be answered very simply if you just look at the soil sulfur cycle itself. This is that cycle we just alluded to. You can see sulfate is highlighted in green. There's a bunch of different pieces to that cycle, but sulfate is highlighted here, and that's because the plant, once again, primarily takes in its sulfur as sulfate, as this negatively charged molecule called sulfate. That's going to be really important to our discussion today. Remember, the way that we've said we will talk about this cycle is that we'll break it into pieces. We've talked about how sulfur enters into the cycle. We've talked about plant available sources of sulfur and have highlighted those in the cycle. And now we're talking about that exiting component. So there are really three pathways by which we can lose sulfur from the soil. Leaching is one of the big ones. Harvested material is also, as you can see, a major source of loss. That's why we've color-coded it in this scheme. And atmospheric loss is a source of loss, but it's really a minor source. Now, once again, harvested material and atmospheric loss will be the subject next time around. Today's subject is leaching. This is the position of each one of those in the cycle. I've highlighted them and given them that same color coding that says whether they're a major or minor source of loss. And we're going to go from here and talk about this subject of loss by starting with a question. You'll remember we've done this before. We've tried to take this information and package it in the form of a question that you might get out in the field or that you might have as you look at things out in the field. So we're going to start with two questions today, and they really can be answered by this subject of loss. Why are sulfur tests so unreliable, and why do coarse, low organic matter soils tend to supply less plant available sulfur? And the answer goes back to what we've talked about before. We're eventually going to look at the cycle. Before that, we're going to set up this case for sulfur tests not being reliable. So here I'm going to make that case. If you go to the internet and you look at several universities near to the Midwest or in the Midwest, you're going to see statements like this. Soil testing is not reliable to determine sulfur sufficiency. The use of a soil test for sulfur is not a reliable predictor of the need for sulfur in a fertilizer program. The sulfate sulfur soil test has been unreliable for predicting crop response to sulfur applications in the Midwest. With sulfur, a reliable soil test to predict the need for this nutrient has not been developed. That's a pretty consistent sentiment across the Midwest. And leaching, this subject of leaching really has a lot, not everything, but a lot to do with that topic, that question, that lack of reliability with sulfur. So the subject of why soil sulfur tests tend to be less reliable partially is explained by this topic of leaching, as I just got done saying. And to really understand this fully, we need to work our way backward in the cycle. So we're starting with leaching, but we need to look at what comes before. And what comes before leaching, loss of sulfur moving with water through the soil profile, is sulfate. That's the thing that precedes loss as we have water percolating through the soil. And I want to now talk about why that would be. It has everything to do with those positive and negative charges. Remember, the soil itself has a negative charge, and sulfate has a negative charge. Just like a magnet, positive is attracted to negative. Like charges are not attracted to one another, and that means all the cations in the soil are attached to the soil particle, whereas the negatively charged particles are not attached to the soil particle. So they just sit there. And when water comes along, we have a situation set up for loss because sulfate is not being held by the soil itself because of that negative charge associated with sulfate and the fact that so much sulfur gets converted over to sulfate. You begin to understand why leaching is such a major pathway for loss. So I think we've begun to answer our second question on that slide we showed just a little bit ago. Why do these coarse, low organic matter soils tend to be the ones that get a little bit more yellow from sulfur in the spring, and why do they tend to not supply as much plant available sulfur? Why do they tend to be the places that if we're going to see some kind of brief sulfur deficiency, it happens there? And we've really answered that by talking about this sulfate topic. Sulfur is rapidly converted over to sulfate, which is negatively charged. And we said that negatively charged particles aren't held very well by the soil. This conversion to sulfate, to a negatively charged molecule, is really similar to what we see with nitrogen, right? Nitrogen is converted into nitrate. Nitrate is negatively charged. The soil is negatively charged, and we know that we can lose nitrogen from the soil. Okay, sulfate's the same thing. In particular, we lose it through leaching. It just washes that negatively not held tightly molecule through the soil profile. If we don't have as much organic material in a sandy soil, we really aren't supplying a lot of plant available sulfur to begin with, right? We said organic material is a major source of plant available sulfur, and if we don't have as much, we aren't really supplying a lot of sulfur to begin with. We've also mentioned that coarse soils have lots of big pore spaces, and so water flows right through them. So there's a lot of opportunity for that water to just take sulfur right with it. Remember, organic material makes those little beads of water that are held tightly by the soil that a plant maybe can access for its own use. We just don't have that with a sandy soil. More of that water runs right through. This begins to explain why coarse, low organic matter soils tend to show some of that yellowing each spring. The sulfur is washed out of that shallow root region into maybe the subsoil, and the plant begins to access it just a little bit more later on and maybe recovers a little bit. But coarse soils are the place where we tend to see that yellowing. And again, it has a lot to do with that sulfate molecule. And this also explains question number one a little bit. We said, why are sulfate tests just not reliable? If you think back to nitrogen, why is a nitrate test not real reliable? Because nitrogen levels move around during the year. We start out with a lot, water starts flowing through, nitrogen's been converted over to nitrate, it's either lost as a gas or it's lost as water moves through the soil profile. It makes it really hard to make nitrogen tests reliable, and the same thing holds on here with sulfur. Because we have that negatively charged molecule, the amount of sulfur that we detect in the root zone tends to deplete as the season goes along. And so it's real hard to get that kind of reliability that we need. That's part of the explanation. And it explains some of these quotes that we have here. Honestly, another half of the explanation is we probably just need more research to figure out where that correlation is between a sulfur test and response to sulfur fertilizer. And honestly, we haven't found that yet. The closest we've come is to possibly using organic matter levels as a way to gauge sulfur response. High organic matter levels, less response; lower organic matter levels, more response to sulfur fertilizer. I want to close this discussion today by emphasizing one more time the similarity between the sulfur cycle and the nitrogen cycle, because there is a big similarity, and it's represented in today's talk once again. You have nitrogen, which bacteria convert over to nitrate, which is negatively charged and therefore is very prone to leaching, especially in sandy, low organic matter soils where the water can run right through. And you also have nitrogen, where the soil tests, because of that nitrate, have not really been historically accurate, haven't had historical reliability associated with those tests. And we see the same thing here with sulfate. We know bacteria rapidly convert it over to a negatively charged particle that's easily leached from the soil and tends to be even more readily leached if it's sandy and low organic matter levels that we're talking about. And we talk once again about those soil tests, partially because of that conversion to sulfate, not being reliable from a historic standpoint. So again, sulfate begins to explain why soil tests for sulfur are less reliable. Sulfate just doesn't hang around very long. And it also begins to explain why some of these coarse, sandy, low organic matter soil types tend to show more sulfur deficiency initially, or tend to maybe be the places where we see a little bit more response to sulfur fertilizer, because the sulfate rushes through that profile much more readily because of those big pore spaces. To be fair, we should mention that there is a little bit of a difference between sulfur loss and nitrogen loss, and that is that nitrogen loss tends to be fairly uniform throughout the soil profile, whereas sulfate runs a little bit more of a chance of perhaps being lost from the upper part of the soil profile and filtering into a little higher concentration in the subsoil. So it's not completely lost from the area the roots might access. Now that wraps up our talk of leaching, which is the major source of sulfur loss from the soil. Next time, in part 6, we're going to talk about exiting the cycle, and this time we're going to talk about harvest, material taken off the field, and atmospheric loss. Until then, we look forward to visiting with you again on Burris Agronomy U.